Hello students, welcome back. We completed problem 1. Actually, we didn't complete. I just completed giving you hints. You have to complete. And let's continue this problem for hypothesis testing. Let me copy and paste this thing. Okay, all right. We've done it before, but let's go through this again briefly. All right, here we go. The article, a trial of lopinavir/ritonavir in adults hospitalized with severe COVID-19, New England Journal of Medicine, published in May 7, 2020 by B. Kao et al., reports the following study on possible SARS-CoV-2 virus treatment with lopinavir/ritonavir, originally a HIV medicine. A total of 199 patients with laboratory-confirmed SARS-CoV-2 infection underwent randomization. 99 were assigned to the treatment group and 100 to the standard care group. The article summarizes the main results as follows. Mortality at 28 days was similar in the lopinavir/ritonavir group and the standard care group with 19.2% versus 25.0%, with a difference of -5.8 percentage points. Mortality at 28 days was similar. That is, no statistically meaningful improvement was found. So, in short, the HIV medicine is not really working. That was the conclusion. But let's suppose that you're doing some mathematical work for them, okay? And suppose that you don't know it yet, and let's get to the conclusion. So if you do it right, then the null hypothesis will win. Okay, let's start off hypothesis. We have null and alternative hypothesis. Null is always no change. Same as before. So the difference is about 0. Unless the problem explicitly says difference is blah blah blah, you just go with difference 0. By the way, null means 0. So okay, the null hypothesis is difference is about 0. Now what is the alternative hypothesis? Greater than 0 or less than 0? You have to think. Do you want this medicine to work so that the mortality rate goes down, or do you want higher mortality rate? You want it to go down. So that's why alternative hypothesis, in that case the medicine works, is less than 0. That's one way. The second criterion, look at the experimental result. We have -5.8. That indicates we have to go down, negative. Check both of them. Most of the problems have both of them explicitly there. So we have hypothesis about the same as 0 and significantly less than 0. If you just use usual equality and just usual less than, fine, I'm not going to take off any point. But here I'm a teacher, so I want to be perfect. So this is statistics, nothing is accurate, so approximately equal. And this is statistically meaningfully small, so a lot smaller. Okay, let's test hypothesis with significance level of 0.05. Okay. All right, let's begin. And we have a number of different methods. And let me start with critical value method. How does the critical value method work? The reason I like critical value method is because I used to explain all those methods, all 3 methods, with about equal weight. And then students who did critical value method used to score higher in almost every semester for about 5 or 6 years running. So, okay, all right, I better emphasize this one even more. That was that is why I'm using critical value method before everything else. Our textbook author, on the other hand, prefers probability value method, which turned out to be usually the lowest score. And yeah, so I don't really emphasize it very much because this is obviously the most difficult method, but our textbook author prefers it, so I'll talk about it too, but in a separate video. Here, I'm going to talk about it in critical value method. Okay, the standard error is something we already did in problem 1, so let me just explain briefly. SC1 squared plus SC2 squared. You see, SC1 already has square root already in there, so taking square root, excuse me, I said it backward. SC1 already has square root in there, so by removing the square root, I'm taking the square, and same thing goes over here. So blue for treatment, red for control, and this is what we get. 0.58 something, and about the same as this percentage point, so this is about 1 standard deviation away. Not very good, as a matter of fact. In natural science, you want something like 5 standard deviation away. Extremely strong results. In biological and life sciences, you still want 3 standard deviations away, but anyway. Okay. Initial picture, outline, center, end, and shade. Everybody must remember this process, and everybody must draw a picture. It doesn't have to be real pretty, but it has to give me sufficient information. Outline, going up and down, symmetric like this. Center, and center, this is null hypothesis. Null hypothesis. We're talking about equal to 0. All right. And then end, left or right? You have to make decision there. Left or right? Let's see, let's go back to your hypotheses. Difference is about 0, right? So about 0 in the center. Null hypothesis, we have less than 0, so you have to go left. Go left. And you're looking for this critical point. Critical value, excuse me, x1. And the reason students understand the critical value method better than anything is because conceptually it's clear. Once you find out this critical value, you can compare the given difference of negative 5.8% point with this x1 value. If it comes here to the right, then closer to null, so null wins. If it falls over here, then far away from the null, so null loses. So conceptually, it's easier this way. Okay, let's find x1. All right, let's find x1. How do you do that? End minus center over SE. Has to be approximately equal to z-score associated to this shading of 5%. Let's go to the z-table. Okay, this shading here should be 5%. Where is 5%? 0.505, 0.495. 5% is somewhere between these two. Do you see? So negative 1.6. So negative 1.64 if you take this column, and negative 1.65 if you take the second column. Somewhere in between, and the difference is the same push. So let me estimate it as negative 1.645. Negative 1.645. By the way, you're going to end up memorizing this because 95% versus 5%, that shows up a lot. So you're going to end up memorizing this formula, negative 1.645. What is the center? Look at the picture, it's 0. You see, you're doing two-sample inference, and difference is usually 0, so that's 0, no problem there. What is SE? You calculated in problem 1. Problem 1a, you did it. So recycle that. What is N? That's something you're looking for. And then find out. I'll stop here. How to find? That's up to you. You have to solve this equation, all right, and find out x1. And what do you do now? Compare that with the given difference of negative 5.8 percentage points, so 0.058, negative 0.058. If negative 0.058 falls over here, then close to null, so null wins. Negative 0.5 here, then too far away from null, so null loses. The problem, as a matter of fact, already gave you the conclusion, so there's no harm showing that to you. This is how it'll turn out. If you calculate correctly, you're going to get negative 0.096 something, and compare that with the given difference. It falls over here in null region, and close to null, null is 0, the center. If it falls over here, then too far away from null. In this case, null wins. See, conceptually, it's easy to make appropriate conclusion if you do it this way. And students used to score the highest if you use critical value method. And I'd like to encourage you from doing that. Okay, let's stop here, and I'm going to talk about the probability value method in a separate value. I'm going to talk about the probability value method in the separate video.